Good evening, respected dignitaries, esteemed resource persons, and dear participants. On behalf of the Department of CSE Data Science, MITS deemed to be university, I warmly welcome you all to this evening sessions of the AICTE sponsored 6-day online faculty development program on smart and sustainable waste management using IoT and data analytics. Our first session this evening is on intelligent waste segregation and recycling using AI and ML. We are truly honored to welcome Dr. Surya R. Asai, Principal Lecturer and Senior Consultant at the National University of Singapore. With more than 27 years of experience in software and data engineering, Dr. Surya has made outstanding contributions in big data analytics, cloud native solutions, and machine learning applications. She has successfully delivered impactful solutions across diverse domains, including telecom, healthcare, finance, insurance, and government agencies, and is also widely recognized as a dedicated educator, corporate trainer, and international speaker. We are especially grateful to Dr. Surya for graciously accepting our invitation and sparing her valuable time to be with us today, despite her demanding schedule. This evening, she will share her expertise on how AI and ML can revolutionize waste segregation and recycling, paving the way for smarter and more sustainable solutions. We warmly welcome you, Dr. Surya, and we look forward to your insightful session. Welcome you, ma'am.
Can you hear me? Thank you all. Can you hear me?
Yes, ma'am. Yes, ma'am. Can hear.
Thank you. Okay, so I'm going to share my slides first, and then, of course, I'm going to proceed with the talk. I have to apologize. First thing is it's quite late in Singapore. It's around 8:35 p.m. here, so the dinner is almost done, and by the time I end the clock, it should be supper time already. So if I'm not in my usual formals, you have to excuse me. So that's the first one. So let's get started. I start sharing my slides and my screen. Please see if you're able to view them. So if
Yes.
anyone can present it in the chat, yeah, okay. So you
Yes,
can
ma'am.
see the deck of slides and
Yes, ma'am.
my
Yes.
codes as well. Okay, thank you so much. So good evening, one and all. And I understand this is a national session, so I welcome all participants from all over the country, and it's very good to be connected. For you, it's the evening. For me, it's almost night. So I'm going to start my talk about the waste segregation, but of course, we will go through a few other um, things before that. So I hope you can see my screen. So this is basically what I want to talk about. Um, Waste management and recycling is not one city or one country's problem. It's a very global issue. And thanks for giving me the opportunity to speak about it, though I've not personally partnered with my environment agency on this kind of project. I thought I will try to share what Singapore is trying to do. And I also want to present two case studies that we have done in the recent years, which is quite popular and expanding all over the city. I also want to take this opportunity to talk about research ideas, but without directly jumping into research ideas, I know it's a faculty development program, so I want to make sure that we put some basics in place. Of course, I would try to share whatever experiences that we have as a very small institute in Singapore. We basically do some practice based research. There are the main faculty, which is School of Computing, which does a lot more than us, but we are a very small institute. We can, so it's my part of the day to share about what we do here and what we do as a simple city country as well. There are a lot of things. Not everything that I'm going to talk about is from my personal experience. Some of them are. So you will see me talk about sometimes projects that are done nationwide. And of course, we also talk about very simple implementation steps and ideas. There are so much we can do, but I'm just sort of idea smithing. So before I go ahead and then talk about this, of course, I have to thank my institution for permitting me to do this talk. And whenever I ask my boss that I'm going to do a Zoom talk in India or I am traveling to some university to give a talk, the first thing he says is, yes, you can go, but please make sure that you make a brand awareness there. So it's my duty to talk about my university, my institute, and then a little bit about me before we move on into this. So NUSISS, as you can see in this building here, we are part of the Continuing Education Institute of NUS. We are very much like the Software Engineering Institute of Carnegie Mellon University, the equivalent of NUSS ISS. We call ourselves Institute of System Sciences. So the building that you see here on this picture is my office. And of course, we do a lot of things there. And if you're very keen on my place, it's somewhere on the fifth floor. So that's basically our den. Now, we've been industry trainers for a long, long time. In particular, we offer a lot of PG courses in technology. So we consider ourselves the practice wing of Singapore. Most of our participants are adult learners, as you can guess. The courses that we offer are mostly postgraduate courses. We do postgraduate diplomas and postgraduate degrees. They are MTech degrees. And as you can see, a lot of workforce passes through us, so we eternally training many of the Singapore's digital transformation workforce. So we have a lot of clients, as you can guess. NUS basically, NUSISS basically has got a larger service portfolio. One thing is we engage on graduate programs, so that's going to be a main part of our portfolio work there. And when we say graduate portfolio, it is not the regular kind where we get students who are fresh candidates, so it's not the case. Most of them are working adults. We do have a full-time track, but a lot of the participants who go through the graduate programs with us have at least 5 to 7 years working experience, sometimes less, 2 to 3 years. So there are a vast number of people who pay and do the entire graduate program. There are corporate companies that send us training candidates to be trained on a particular skill or a particular domain. So this is what we call as executive education. We also have an international wing, which basically partners at a country level. We also offer program in many cities. I think a recent one was with Hyderabad. In India's case, we also did a few others in many other Asian countries and the rest of the world. Of course, we participate on industry. When industry wants to do any kind of architectural appraisal, vendor neuter discussions, when they want to go in for sometimes appraising the different governance policies, etc., they usually get us to do neutral consultancy as well. Of course, our own house has got a very small career services wing. This is mostly targeting the young full-timers who are looking for workforce operation. So we call ourselves a bit more inclusive than the regular schools and faculties. The reason is we offer very small modular programs. So if you are a corporate employee and you want to just upgrade yourself on 1 or 2 skills, you come in for the executive course. Sometimes you want to specialize on something so that you can add a special portfolio in your CV, you go for the graduate certs. You can stack up a few graduate certs and make it into a master's in technology. And of course, we also work with government to government partnerships. So there are a lot of things that we do at ISS. And if any of you are interested in any of these things, please drop me an email and I'll be very happy to connect you. Now, what am I doing in ISS? This year, I'm completing 20 years with ISS. When I joined NUS, I was thinking, I was very interested in doing research because you can see I'm a very curious person. I used to teach when I was in the south of India. I come from south of India, and my husband is a Malaysian Indian. I'm an Indian, so we chose to make Singapore our home. So I used to teach before coming to Singapore. So when I came to Singapore, I joined the workforce. I was consulting on a few companies. So the last company I was working for was IBM Singapore. So after that, I thought academy was still in my heart. I wanted to do a PhD. So I joined ISS NUS. And then I thought maybe after doing PhD, I will leave. It's been more than 12 years since I finished my PhD, but I still seem to be happily enjoying NUS career. So definitely they are treating me well. As a person, I enjoy crafting codes. I'm a software engineer at heart. I always enjoy building systems. And of course, I'm paid by NUS to teach those skills to adults. It's more an andragogy institute than a pedagogy institute. We also do practice and consulting, as I said. Research for us is an afterthought. So if we think there is something interesting and if the industry partner is willing, we go and publish about it. Otherwise, you won't see us publishing as much as a normal institute. So that's the disclaimer I have to tell you upfront. And there's nothing much about me except that I've been always a computer science student. And these days, I find AI and data science a lot challenging. So, what do I do at Institute of System Sciences? I specialize on cloud and data engineering. So, if at all you go through any of the technical courses that involves building digital solutions, managing AI-based data platforms, then of course you will definitely see me coming and doing some part of the curriculum or part of the consultancy, whichever is basically happening. And that's pretty much about me. So let's get started. Of course, thanks to my boss for allowing me to talk about it here. See, the moment I saw the title, I was a bit taken aback because normally when I apply data engineering and the AI libraries in my practical consultancy, I've done a lot in manufacturing sector. I worked with financial organizations to implement such kind of AI pipelines and look at how the partners extended. I've also done some agrotech projects. Okay, so some with my parents' company in India. I come from south of India, and my father is an industrialist there. So basically, we have done some work on agrotech. I've also worked a lot on healthcare here and there. But waste management is pretty interesting, though I've thought about it as a simulated project. I've not personally partnered with my SEMCOR, which is Singapore's waste management group of government agencies. But there are many other projects that my students have done in the past, and of course we have guided them. We have even went on board to look at how they've done it and things like that. So I thought we will definitely share those stories and then get into how AI can influence these areas. See, I'm sure climate emergency is not only felt by us, it's a global phenomenon. Everybody looks at the climate crisis here. So we are looking at definitely an emergency. I don't know if it is true for you. So I consider myself a digital nomad because I live in Singapore. My parents live in Chennai. My in-laws live in Kuala Lumpur, and my son lives in Melbourne. So we basically distributed all across, and we constantly sync digitally. So many of the family conversations these days is all about the heavy rains. I'm sure many of us would have experienced this as well in your respective cities. So definitely climate is changing. Is it changing just because of the time that the globe has been moving around? No, definitely not. The complete emergency is caused by human beings. I don't think any other living thing is to be blamed for this crisis. So the entire blame is to be by human actions. We tend to have a completely unrealistic way of producing and consuming patterns in our habits. That is to be blamed. Of course, everybody starts quoting industrial revolution because that's when engineering started scaling a lot. eh. I'm sure you have seen how industrial revolution started, and then how massive production became very much possible, and how we started becoming a very consumer oriented society. Whether divided by democracy or not, across the globe, our patterns and behaviors have changed a lot. So there are three things I want to highlight here. You see, energy, the kind of materials that we consume, and of course, our food habits. So these are the three things that has changed ever since we went into the industrial revolution. Now, having said that, does it stop there? No, so that's basically what is a bit worrisome. The moment we say energy, the only energy that we sort of get to use is from the solar. That's the only clean energy that is freely available for us always. So of course the cleanest form of energy is also from the sun. Interestingly, on the side note, energy is received as energy packets, and these particles in physics is called as photons. My father named his company as Photons because he thought the energy or Shakti form is basically photons. So he always was very fascinated about how kinesis happens. When we say kinesis, how energy formats are changed from one to another. So sun is good, that's fine. We have been doing this kind of solar energy for a long time, but we have not done enough, and there are many countries which are bounded by geography which have restrictions on exploring sun as a very key form of energy. So of course the second form of energy, clean energy, comes from non-fossil fuel forms, so there are many wind, so on and so forth. And of course, the third one, which many of us, including me, consider as the holy grail, is the nuclear fission. Nuclear fission seems to have all the parameters to be a very good alternative, but the problem is it is very, very difficult to make it practical. eh. So that's one of the reasons that people are yet to find out. Of course, though we know these things work, we are yet to figure out how to sort of scale them, engineer them. So that seems to be a very long distance pipe dream as of now. Of course, there are many countries racing into it. So when you talk about energy, the first form of solar energy is quite prominent in Singapore. So Singapore is, we always call our city 1 degree north. So compared to many other countries, we have a lot of solar panels lying around. And I must say that we do put good use of it. So we are very industrious city. We don't have many natural resources that other cities and big cities and states claim of. So our number one is human resources, right? So we sort of tend to use as much green energy as possible because we are very, very conscious of the footprint we are creating. So we were the first to try solar panels on seabed. The reason is our city is too small, and of course you can see that we have done very decent outcomes on that, and of course we want to partner with other nations to go inside all this energy. Now when it comes to material, though we don't have any natural resources like many other cities, like the iron ores or others, we do consume and procure from all over the world. So we have to handle a variety of material that comes into the city and goes out. And of course, like many other countries and cities, we also have food as a big issue. So when I say energy, material, food, these are the three prime things that every city, every state, every country thinks about. So what we are trying to achieve with all this AI and analytics modeling that we do, either in our institute or all the world, is we are trying to form a new way of industrial revolution that basically sorts of churns down the carbon footprint. Okay, so the essence is always the carbon footprint. And the reason we are so against fossil fuel, as you can guess, is the amount of carbon we release is much more than what was originally present in the environment. And that's the reason we are looking for such kind of cleaner ways. So, any kind of waste management project that you're going to deal with is an equation between how much is being produced and how much is being consumed and what is the wastage. Okay? So, that's roughly how we define wastage, recycling, and things like that. Why I have to tell you all this big story before getting into the DLML is I don't want you to assume that only the garbage collected in the cities and the garbage processing becomes waste management. No. There are different forms of material that's being collected, and each government and states, provinces, cities basically have a very ingenious way of thinking about how they're going to segregate them, how they're going to process them, how they're going to recycle them. So there are a lot of questions around this spectrum, and it's a very thriving research area. So if you wanted to do research in any one of them and you're very keen to look at idea smithing along with me, I hope you find the rest of the session useful and there are some kind of pointers that you can take away from this. So let's get going about statistics for my city because as I said, I've sort of become a nomad or a bit borderless. I think the globe has got 50 good cities to live in, and 20 of them seem to be racing against one another. The other 30 are slowly following. So this is the equation. So I belong to Singapore. Many of you belong to many other cities. That's it. But Singapore's challenges are very unique. Okay? So for example, Singapore is smaller than New York. Okay? Our land is very, very precious. We don't have a big piece of land like many other cities um, claim to have very proudly. So for us, the problem is we are very, very densely populated. Of course, I cannot say this because my parents would say Chennai is the most denseliest populated city on the whole globe. Very equally followed by my in-laws claiming Kuala Lumpur is also racing. That said, at least they have an option to expand. Singapore, it's being an island by itself, it's very, very scarce. So definitely it's a critical factor for us. And according to our National Environment Agency, we produced 16.3 billion pounds of solid waste. And that's a lot, as you can see. But it's a very buzzing city moving around, so you cannot say that we can simply curtail these things. Now, what we have been doing so far, because you see, just like AI has gone through generations of modeling techniques, AI has been around since the 60s. The 60s, 70s, 80s modeling technique was different. The 90s, 2000s, and 2010s modeling technique was different. And of course, after the transformer era, the way that we create models are completely different. So AI has gone through like 3 or 4 waves of revolution. The same way, as a small city state, we've also gone through 2 or 3 ways of recycling and waste management challenges. One thing that we have done in the past is we started creating all this wastage that's being finally burned to landfills. So we have a man-made island, being a land scarce city country, and the land island is already 90% full. It's not a bad thing because you can look for this. There are plenty of documentaries available in our own news channels, which is CNA Insider, and also the global channels like National Geography, and so forth. We call this a Simakau landfill. It's a Malay word. And we are expecting the whole island to be done by 2035. But we have been doing that in stages. And we don't want to create an artificial place. Very interestingly, we want to make sure that we sort of merge into the fauna and flora and the animal kingdom of this particular biological zone. So when we created landfill, the first thing that we wanted to have is to create vegetation. We did not want to spoil the ecosystem. We did not want to make an imbalance in the island by making it unlivable. So when we say landfill, you cannot imagine that as a pile of ash. It is usually recycled. It's been used. We try to not contaminate the sea as well. For many countries we have rivers, ponds, and sea. For us, mostly it is sea because it's as you can see, it's a small island state. So we have basically done enough platforms so that the fill doesn't mix into the sea. But at the same time, we have been able to make some biological sense of the landfill as well. So we have grown trees, we have brought in some birds from nearby, we have the natural habitats moving in as well. So these are the things that we have been experimenting, and we want to delay this as much as possible. We do not want to create more and more landfill islands. Okay? So that's why we are very rigorously employing AI into many of these spectrums, as you can see. And the only way that we sort of, and as you show the images that has got this font is from Gemini, as you can guess. So the current waste management strategy is incineration, but uh, most of the time we try to make sure that it is the last possible resort, so we as much as possible classify, recycle, and when that is not at all possible, the last part goes into this burning. So we have a end-to-end plan that talks about waste to energy, and it is not just done by one agency, folks. So it's a top-down as well as a bottom-up approach. So there are many agencies that are looking into waste management strategies, and it is also a citizen's responsibility. So it's a two-way problem. So we have a lot of plans that are working 7 days a week. We have 4 active plans throughout the island, and as you can see, they are constantly working. When you look at the statistics, we are trying to see how to reduce it. In 2021, we were able to do only 42% of the trash collected went to this kind of end cycle plan. And we are trying to reduce the target every single year. And we are also trying to handle uh, different kinds of material in different kind of site as well. Each site is trying to specialize on how the incineration happens. So that said, when we say that we are trying to burn waste, you have to understand that it is not being sent directly to the environment, because the moment we say incineration, people imagine things like deforestation. So there are some places where we just do deforestation because we wanted to do farming. We just burn it without any purpose. For us, a lot of our energy is hydro plants, steam generated plants. So every rainfall that comes in is important for our hydropower, and every heat that ever gets generated in the country is very important to us. Of course, we don't live near the gyros, the natural gyros like Indonesia. Indonesia has got some mountains, natural gyro, and then steam is produced, and then you can do this kind of looping steam. You can look into this project. There is this company called Everloop that basically drills fish fin kind of structures, whereby steam is collected, heated, and then it's being used to run the turbines for power generation. For us, the heat burning completely goes to the turbine generators for electricity. In fact, they easily generate. We started with 60 megawatts. Okay, right now it is 120 megawatts per hour, and this basically is enough to light around 2.4 uh, to 240,000 households, as you can see. Right? And this basically contributes to 3% of the national grid. Of course, we have other means, as I said, like solar and so on, to burn in. And sometimes we also have to do fossil fuel burning. We try to keep it at the moment very less. I'm not sure of the percentage, but we have been constantly trying to not rely fully on fossils for our energy needs. So the next question comes to people's mind when I say that we do incineration very nicely is what happens to the fumes, because the biggest challenge in setting up these kind of plans is we have all kinds of waste that comes mixed up. So the toxicity and order that comes out of the plants is a big question. So this has not happened in a single day. So we have been experimenting these things around 30, 40 years of digital innovations here. We have very advanced filter systems that basically removes all the toxic smoke and odor from the waste smoke. We also have filters, so very ionized catalytic filters. So these are also quite capable. And of course, the final form, which is less than 3%, comes back as the waste that gets back to the landfill. So we have large plans to look into it. Now, what we have not very paid much attention is basically categorizing and then trying to do this based on the material that we have to handle. So suddenly when we started doing these statistics in the last 10 years, NEA is basically the National Environmental Agency, by the way. They basically published a paper that highlighted to us the trash crisis. The thing is, we, of course, as I said, 55% is basically recycled, only the rest goes away. So when we analyzed it, there was a large portion of plastic waste that was not treated very well. So this, as many other cities would have discovered, it comes as a bitter surprise to us. And you see, if you think about plastics is quite crazy. So um, just for yearly consumption of plastics, the entire globe use 8% of its fossil fuel to create this plastic. So that's a lot if you think about it. If you really need to invest so much, no, not necessary. The reason we had to do this is because people are not aware of such things about how plastic deteriorates and doesn't deteriorate. The disposal of plastic has not been very educated or habitual to the humankind. So reclaiming this plastic has not been woven into our fabric. So we have been very mindlessly doing this for quite a few decades. This is all the side effects of, as I said, the Industrial Revolution. So we had to start thinking about this. Of course, just like every other city, we started binning them first. So we discovered the blue bin philosophy, like whereby people consciously collect those kind of recyclable plastics into blue bins, and then of course we additionally do manual sorting, and then if it is not recyclable at all, we intensive. And if this was going to continue, we realized that this is going to increase by target. So that is why we wanted to employ a lot of automation inside that. So we realized when the landfill is to be manually sorted, it's close to impossible. So that's where we started creating this kind of AI and robotic assisted recycling help. The other challenge that our city faced was contamination. Though we have colored bins, though we basically put in these kind of recycling units at every government apartments as well as private properties, 40% of them are basically not reusable, clearly because they're not cleansed before disposal. So this basically means segregation is a challenge. So it was a long debated problem in the 2020s. So 2020s, 21, we basically thought a lot about these things, and that is where we started looking into segregation at source. So just like in many of the cities, we started doing it. But then what happens is we still had to be dependent on manual and human behavioral changes. So this basically was not a very effective way of segregation, and of course, this did not contribute to the back end efficiency at the plants that I was just now mentioning. So this is where we started exploring AI. So AI comes into a lot of these things. That said, it doesn't mean that the 2020s project was the only thing that we did about waste management and recycling. The solar panel project that I spoke about, I think we had a bunch of engineers who did masters with us, and then the seabed of solar panels was done as early as 2014-15. We started simple prototypes, and then we had a massive bed of solar panels on the sea. But of course, we have very limited water boundaries, as you know, so that's why we couldn't scale beyond that. As a superfluous filling of the project, we tend to sort of change all the public housing, which we call as HDB, Housing Development Board, which is the government agency responsible for the housing. 80% of the living spaces in Singapore is apartments. So we sort of stop the roof access mostly for privacy and security reasons. So government took over these spaces and then changed them into very clear solar panel farms. And of course, the car parks, which are 4 to 5 floors building, at least in my estate, what we tend to do is roof gardening because land is so scarce that we sort of harvest on all these things. I would say the big change of role in AI came after the invent of transformers. I'm sure many of you you're doing your projects in ML and DL these days. So it's a very innovative thing that was contributed by Google. So you can see that transformers change the way that we start doing hyperparameterization, hyperfeature engineering, and so on and so forth. So AI sort of had a big say on how we tend to do these things. So the nation started deploying more and more of such kind of initiatives. In fact, the last 4 or 5 years, I think our investment on AI has grown drastically up. So we use AI for segregation, for recycling. We use it for we want to become the model city blueprint in many ways, and we are very happy to share all these stories with other cities which also want to thrive and change. Because Asia is in a tipping point. So India, China, and all the Southeast Asian cities, we are in a global trade tripping point. And as you can see, the world order is changing. So it's important for us to take leadership and then do things completely different from what the previous 40, 50 years of thinking was. So there are a lot of funding that is going on in our city around these kind of waste crisis and trash management. So there are many initiatives around. I just wanted to select two so that I sort of give you ideas because as faculty, you may want to try things which are explorable in your labs. So the team got to me very late. I think I was given like 10 days to think about it. So every time I used to drive to work, I think about what can I share to other faculty members, which will inspire them to start thinking about research. So you can look for this project called Bingo. We have plenty of YouTube videos and context about it. So what we are trying to basically do is smart sensors. Okay? Uh, we know that we have this bins, segregated bins. Being a digital nomad, I have the, I should say, opportunity or blessing to travel to many of these growing Asian cities all over this side of the world. Every time I see the segregated bins, when I look inside, I feel very bad because there is this clearly labeled general bin, which is supposed to have the generic food trash. And then we have the paper trash, plastic trash, and of course, special trashes for our electronic equipments. But nevertheless, when I really go to these cities, the general waste, including sometimes my own, the general waste is basically so overflowing that it basically gets put down on all the other colored bins as well. Right? At least housing and development agents, we basically have some kind of reward or penalty system whereby we have some kind of governance going on. Industry, at least to some extent, but this kind of public and community spaces is becoming very challenging for us to segregate waste. So fair price is basically the national trading unions set of chain of um, retail outlets for us. So we are not very corporate in that sense. The government regulates the pricing, so that's why it's a fair price as it is named. And A star is basically the entire city states country state, I should say, a research organization. A star has got many other departments. Usually A star works with your uh, uh, Ministry of Research as well. Okay, so they basically started piloting this bin called Bingo. Originally, this bingo was put at big shopping malls. They started with three and then they started testing more and more. These days, I commonly see bingo in any of the community spaces. Okay? So the other day, I was even seeing the national libraries started having bingos. And very recently, I also realized they are basically used on MRT, certain selected MRTs as well. We are still experimenting. Once we sort of get it right, of course, we mass produce. That's usually the case of any kind of researchy things that happen in Singapore. So, what we tend to do is we basically use smart sensors. So, these sensors are capable of sorting. When we initially started Bingo, it was like a gaming, because the whole idea of recycling basically needs a cultural revolution, which means people have to change their habits. And sometimes you put it on the wrong bin, not because you are determined to contaminate, but sometimes materials are very difficult to guess as well, because packaging and marketing agencies are doing such a wonderful job that many times I get confused about material science as well. So happens to anyone who wants to wonder how the binning goes. So we sort of have uh, is there a question? There's a raise of hand. Should I continue? Okay. So I'm going to go on. Okay. So basically, what we try to classify as recyclable and non-recyclable, because we want to control the contamination issues, as you can see, and of course, we want to provide step-by-step guidance to the user as well. So the idea is to educate the general population and also correct recycling habits. Because just by labeling you don't enforce anything. So it goes a long way. So adoption basically comes with some kind of entertainment as well. So when we originally started the bingo project at fair price, it was like a game. So we used to see a lot of teenagers hanging around finding the penalties and the rewards in the system. But slowly we started making more extensions to it. Of course, ASTAR is the sponsor, and every higher learning institute basically came up with plenty of prototypes. So that's why you can see it's become a daily thing. There are a lot of models, there are a lot of projects around these things. You will be able to understand how we have done that in the research website. So that's why I've bookmarked these websites, as you can see. And the other case study that I wanted to talk about up front is multispectral AI. So this is also very, very popular in Singapore. And of course, many other Asian cities are trying to purchase these equipments as well. I've not directly participated in this, but my NUS team, which is under the AI Singapore, does plenty of prototypes around this. So what we tend to do is you see, material sorting is a big challenge. And the kind of plastics, there are like 5 or 6 kinds, and then we have to capture and then classify them on the conveyor belts and so on and so forth. And we want to do that in a unsupervised manner, so it's very important to make the whole unit unsupervised, reducing the amount of human intervention that happens on the belt. So of course, we basically trying to try use different robotic platforms and things like that. You will be able to study about this on the AI Singapore website, and also there are plenty of YouTube videos. I just put one here so you can look or watch it, how we try to classify these things. Sometimes it's done by the government, which is SEMCAP and many other agencies collaboratively. Sometimes we also take help from industry partners, so it's basically um, a joint venture. It's not always completely done by A-Star and agencies. So these are two interesting projects that you can take a look at. So if you're looking at how AI is currently being subjected to these kind of waste management and recycling, these two case studies are brilliant for us to start with. Of course, NUSISS is also doing e-government training. So if you are a bunch of candidates from any of the government-sponsored program and you would like to come attend these courses, I think there are plenty of courses done by NUS as well as NTU on such subjects. Okay, so you can take a look at it. So the idea is we have many, many stages. And though I just spoke about two of them, The reason I picked only these two cases is these two are very reproducible, given that if you have a lab and you have equipment set up, and if you have a way to ask for grants and collaboration, these two are very simple, low hanging fruits that the teams can start with. But there are plenty of ideas. And of course, you can also partner with the industry to do such things. I'm always keen on looking at these things because it's carbon footprint is something that I always look for. There is also a recent case study that I came across from Bangalore, which also does this kind of plastic segregation, 5 layers. But I've not gone to the plant. I've not seen how they do it. Of course, I know how it is done here because there's a very brilliant agency and industry partner that does it for the last 15 years very effectively here. And I happened to do one of the project supervision, so I had a chance to go in and see that. So when you talk about waste management, there are many areas where AI can be employed. Okay, so it is not really all about robotics and unsupervised classification algorithms and multispectral cameras and material segregation, etc. Sometimes even efficiency can be looked at as consumption patterns and producing patterns. You can look at ways for cost reduction at smart home projects. We always do that. Yeah, so, a very popular IoT experiment for us at our Institute of System Science, you can even see that once published one on some quite a few years ago, 6 or 7 years ago. It's about smart housing, whereby we sort of estimate active people in a home so that we could be able to control the air conditioners. Because see, one thing is we are very near to equator. That's a good thing because we have a lot of something. That's a bad thing because we are a lot of us are residing in high-rise building. Also, our office environments are a lot of high-rise buildings. So this basically means we need the help of air conditioners to be able to live in the city. So carbon footprint must include a major part of this. So when we talk about efficiency, we were looking into central coolers. And there were plenty of ideas around it. And even now, the government has initiated the replacement of old technology by newer, greener forms of cooling management systems. So that's the efficiency part. Of course, cost reduction is about trying to be very careful about how we expend these resources. So that was the smart home project I was talking about. So we sort of switch off electricity usages when we realize there's nobody in the room. So you would have when you visit even in public spaces, this is very common in Singapore. So in restrooms, in common corridors, um, in most of the high-rise office and living spaces, co-living spaces, we always tend to be very careful about the electricity footprint. When we realize there's no human activity, we sort of put it to as minimum as possible, day or night, irrespective. And of course, we spoke about binning and many other recycling that we spoke about. Of course, a lot of governance, health, and safety projects have come to the horizon. We are talking about policies, we are talking about layers, and we are also talking about AI based SLAs and sustainability perks that the government wants to think about. So there's a lot of things happening on the governance area as well. Every project that we take about, whether it is a simple bin sorting or it is a material sorting project or it's going to be a recycle, we always look at circular economy. So I think you would find it evident in other projects that we did, like for example the landfill heat was used to power the steam turbines. Every time we always try to aim for the zero carbon footprint, so every carbon releases gets absorbed again. That's the whole idea. This is inbuilt in small scale, medium scale, as well as entire large scale projects. That's something that we constantly thrive to achieve. And of course, scalability. I think scalability for Singapore is much smaller than big states and countries that are around in Asia. But never mind, I always like to think Singapore is the smart prototype. We try many things, we fail, and we find out the formula, and we are very happy to share with the human race anytime. So that said, there are three areas. One is basically intelligent form of collecting, segregating, and this basically involves a lot of automation and robotics. And of course, deep learning and machine learning has become very default these days, being applied in sustainability goals. So every time a project gets sanctioned or we want to try something for the city, the carbon footprint also brings us awareness and taxes and many other things. And of course, we also are looking for technological breakthroughs. Yeah, our city state, as I said, is very small. We are totally 6 million people. That's it, So we always are very eager to learn from other technical giants and then see how we can benefit as well. So all these three are always happening in Singapore. In recent days, what I realize is there are two kinds of project that constantly happens in my institute, at least with what I see from the master's projects that we do. Every year we get plenty of deep learning on the text. And the last 2 years has been very, very interesting because we start looking into images as well. Okay? Thanks to vector databases. We used to struggle with the semi-structured and unstructured data, so a lot of things that has changed. So I thought I'll talk about this as well. Okay? So many of us think AI is just a library. Why I want to talk about data is I want you to reimagine your projects because somehow data science and data engineering is always understated. Okay? The reason I say this is once upon a time when you want to build a digital solution, you will try to write a piece of application through a programming language, and you tend to have a persistent data store which is 99% of the time it is a relational database management system. This is how you look at technical solutions. We have been doing this for 60 years, but now the equation is changing. So data is no longer combined into relational databases. So now you have many newer forms of data. So you talk about object stores like Amazon S3. You talk about your own data center object stores like MinIO, for example. You talk about in-memory databases like Redis. You talk about large-scale cache management, which can be mounted on clusters, and that's basically what Kubernetes container storage interface is all about. Okay? So it's about how you mount drives and make the drives help you to manage the state of your application. We also talk about many other new forms of data. We talk about document data sets like Mongo. We talk about graphical form of data and querying like Neo4j and Tiger Graph. We also talk about columnar family, the famous Cassandra database. So data is also trying to modify itself into many forms. If you take the first iteration of data engineering, it is transactional processing system, which is tightly asset transactions, and then OLAP systems, which is basically for BI. And the end game of BI is always some kind of visual report. Okay? And it is not as active and real time as these days systems. It used to be like an offline thingy that happens once a week, once a day, once a month, once a year, those kind of BI systems. But now you see a lot of things have changed. Not only is data expanding, as I said, you can't contain them into RDBMS anymore. Everybody wants it to be scalable throughout the globe. So you're talking about sharding, you're talking about replication, you're talking about NoSQL systems, new SQL systems. What I find it interesting is how we harness this data inside as well. That is also changing a lot. Okay? So you are faculty and you want to do research on this, and of course you thought about all the AI models, but data is scarcity. I don't know whether you realize this. For us, we always say data is the new oil because companies are not ready to divulge their data. Organizations do not want to share data. Governments, some agencies are very tricky. You cannot share, for example, defense. So there's a big set of data scarcity. Of course, when data was initially becoming a very interesting thing, there were a lot of data hackathons, as we call it. Like Kaggle is a big hunting ground, then Zenata is another big hunting ground. So these are all good, cleansed, clear data, but it is not realistic. Because your raw data is very dirty and your raw data has got all the beautiful insights that you can make intelligence from. So now you got to reimagine your three-tier architecture that I spoke about earlier. You have the browsers or some mobile phones that consumes your data. You have an application that is dominantly in one programming language, and you have an RDBMS system. So this was the three-tier in transactional processing. If you take data warehousing, you have a layer of transactional data systems. You will pull them into your data warehouse, and then, of course, you build OLAP engines to work on them. So this is typically how OLGP and OLAP was working for a long time. And now the equation has changed. The whole data layer is being replaced. The RDBMS is not a dominant force anymore. The whole data layer is open, eh, which basically means you are trying to qualify much more forms of data. You're talking about data in use, you're talking about data in transactions or at rest, you're talking about moving data, messages and streams, and so on and so forth. You're talking about structured, semi structured, unstructured data. You're talking about different speed, velocity, processing, veracity, trust, variety, and of course, volume. Most people think data is always volume, but there are many other metrics. In fact, if you look at the research, I think my mentor wrote a paper about 11V. So V basically is our first wave of awareness about how we measure data quality. Of course, we have come a long way. This year, ISO has released data quality. I'm sure many of you have read the data quality standard. So there are a lot of interesting things that's happening. So as an initiative from the government, it initially started with 5 countries: Singapore, Canada, US, UK, and Australia. So we were the first 5 to start the open data initiative. So we started creating data for good. We anonymize data and we put data out there so that data scientists and software engineers can come up with very innovative ideas to help the government and the community improve. So it started like this. Now I'm seeing every government is starting to put these kind of open data sets. So that's a big boon for researchers like us. Many times I look into open data sets from Singapore, from Canada. These days I'm also starting to look at data sets from India. There's been last 2 3 years, there's so many data sets that come out. So it's very interesting for us to apply all the MLDL libraries. In fact, we have not explored more than 60% of the models that we currently have. And the yardstick is so amazing. There are so many innovative ways in which you can apply. So Singapore's open data portal is usually where I go to look at any data set that I want. And of course, the equivalent of it in India, I realize, is data.gov.in. In fact, I'm working with a few universities in the southern part of India, mostly Tamil Nadu. They're basically trying to come up with data sets on agriculture. They are coming up with data sets on energy consumption patterns and things like that. So much of it is being cleansed and contributed back. Right? So I'm sure each of you have a localized data set that you're probably working with on your research team to look at all these things. So explore such hunting grounds. They are great places to start. And of course, you see, when you start putting the pipeline in place, it starts with identifying heterogeneous data sets, looking at what is the strategic advantage of considering new data inputs, and of course, using the right technology. At least in my team, where we focus more on the engineering and the technology, we sort of tend to use many cloud native frameworks. PySpark is one that we usually enjoy using. One thing is the scalability is given, and two, Databricks also provides a lot of interesting uh, text analytics as well as vision analytics libraries. So that makes it easy for us to harness text data and semi-structured, unstructured other forms of data. So we take full advantage of such things. And there used to be a big dichotomy on data systems. So at one end, there will be this cloud guys who provide a data warehouse as a very scalable solution, example, Redshift and Snowflake. On the other hand, we have the open data lakes, which was very much propagated by Databricks because they invented the Spark, as you know, and it's a complete open source. So they basically go for more governance security layers and machine learning, deep learning, and streaming. I've been working on the right side of the spectrum a lot. So we've been using a lot of NLP libraries and vision libraries on larger data sets to understand how it can be of any kind of insight to the partners that we work with. Of course, at the end of the day, any kind of machine learning library that you're going to build is a pipeline. You can sort of take as much inputs as possible via databases, APIs, streaming platforms, and whatnot, and then of course think about the storage design and the layer that I was talking about. A whole data framework evolves out of this. And of course, there's a trend here that I want to highlight. People don't call us lake and warehouse anymore. We call it as lake houses. So we are sort of fusioning things together. We no longer segregate structured data sets and semi-structured, unstructured into two different bins. A lot of these things have changed. Another thing that we centrally practice in the recent days in our research projects is we separate data cluster, which is the storage cluster, and the compute cluster separately. Okay, so this way, it sort of helps us to create workflows that are rightfully useful and serverless as much as possible. This sort of reduces our research footprint and prototype footprint. I'm sure you can also consider such things. Plenty of workflow tools. I used to be a big fan of Airflow. Now I've sort of compromised Airflow for ML flow. And so plenty of my production prototypes that we work with on the data sector basically uses ML ops. One thing is it is GitOps compliant and it is Kubernetes friendly. So that makes it easy for us to carve out a cluster based prototype for such kind of AI and data engineering pipelines. So, what happens to the data spectrum is you become the fair bit provider of all the raw data. Basically, you also are the initiator for the feature engineering that happens on the higher layers. So you sort of architect all sort of raw data, collect them, stage them. Of course, there's this famous medallion architecture where you collect raw data, process them and cleanse them, call that as bronze. Prepare your ETL and ELT scripts, call them as silver. And then you try to run your AI models and analytical models, and that becomes gold. So every layer improves on the insights that you tend to offer. And of course, we have this reverse ETL where the insights go back and then turn to be ingested in again. So that's an entire cycle that we like. And of course, we teach plenty of tools to do this kind of end-to-end pipeline flows, tooling and automation. My favorite, of course, is Kafka and Spark Stream. Of course, there are many other alternates in each layer. So, in general, when you talk about these kind of deep layer models, on the software terms, we call this as Lambda and Kappa. Lambda basically is an entire architecture that is around batch processing, a bit near real time processing and serving. But Kappa is basically a pure real time architecture. Many times people ask me what's the difference. Though the Lambda and Kappa architecture are theoretical terms, and of course, please don't mind my diagrams. I have this habit of using Excel draw and drawing a lot of diagrams in my class when I lecture. So when I think about something, I just draw. So don't come back and sue me. I'm just trying to make things easy for us to ingest and use. So what happens in the Lambda architecture is the latency. You're talking about latency, which starts from seconds to milliseconds of response time in a Lambda architecture. While on a Kappa architecture, you easily talk about latency which is 10 power minus 6 seconds and lesser than that. So that's very interesting. And that's the key differentiator between Lambda and Kappa, of course. And again, this is my diagram. I'm trying to visualize things, may not be the best, but I've been teaching this kind of AI and data engineering put together to end-to-end pipeline building. I think I started teaching these things in 2016. Then I started doing consulting the subsequent year. So around 9 to 10 years, this is what is my summary of understanding. You always separate your storage and processing layer. So you can see that your storage basically is the basis of your architecture, and your storage is not enough. So you have to segregate them to layers. And not only that, you have to cover a lot of cross-cutting concerns. These concerns could be metadata. So now we have Iceberg. That's a very cool tool that I'm using in a lot of my curriculum. And then, of course, Iceberg has a combined metadata, which is automatically built. The prototype is Apache Polaris that we use. It's a plain free version, but an equivalent of it is available in Databricks as well. Databricks uses something called as Delta Live Tables, DLT. So that could be something interesting, and you can explore that as well. Because I'm talking about it, maybe I can also show you something. Databricks, last 2 months ago, Databricks introduced this free edition. So you can see that we are very much trying to promote that. So this basically allows you to build a deep learning pipeline on a data set. But of course, the free version is a serverless version, so it allows only very minimal data sets and minimal code. But if you have your research grants, you can go in and buy or subscribe to more clusters, and you can store larger data sets to be able to do that. And of course, Databricks goes by the medallion architecture, as we call them. Draw, silver, bronze, that I was just talking about, was one of the very famous way in which the lake house is usually set up. So there are a lot of things that you can do across. Of course, Snowflake is another popular one, very equivalent to Databricks platform. Dremio is another platform. Recently, we also have a few others like Star Rocks. In one of our recent manufacturing consulting, we used Star Rocks to collect all the images to look at how wafer fabrication testing can be done. So the compute layer basically is in multiple stages. You ingest, you prepare, and then the processing is where you basically connect to any of your libraries. Whether it is Gen AI or deep learning, or your classical machine learning projects, you apply these things as pipelines. One pipeline is never enough for your prototype, so you'll have multiple pipelines. That's where you get to create workflows, and then after that you basically visualize the insight. Sometimes the insight goes back. As I say, it's reverse ETL is also possible. So there are a lot of choices, as you can see, the kind of databases you want to use, the kind of file storage and object storage you want to use. What is your data formats? How compressed is it? Are you trying to use any kind of standard pipeline libraries? Are you trying to use a platform to host them? How are you going to do performance engineering, logging, and monitoring on that? How are you going to build your warehouse or your lake house? What happens to fast moving data, which is stream? What happens to slow moving data like messages? How are you going to process them? And no one single system is done by one project, one programming language anymore. So we have sort of become polyglot as well. Microservices, serverless architecture, all of them propagate polyglot programming. So we usually use the language that is very suitable for the use case. Many times for DL and NLP, I've seen Python very popular, but the equation may change with computer vision coming in, because computer vision by itself is a very interesting area. Out of the 11 million sensors in your human body, 10 million sensors are dedicated just to eyes and retina. So you can see the intensity of computing that happens in vision. So we have now just started all these kind of vision. That reminds me, there's another interesting case I want to talk about. Netflix recently did. Uh, there is an engineering blog from Netflix that basically uses Sana DB, okay, for so you can see that they basically talk about how they are trying to do machine learning for their movies. Because Netflix being a very forefront corporate, they always have the history of trying to figure out things about machine learning pipelines and donating them as projects, open sources to Apache. So recently, what they have done is they have used a media table. This is the new extension of Iceberg. Iceberg is a raw data with the metadata layer that I was talking about, right? So these guys have taken that and then extend the table format to cover multimedia. So that was a brilliant move. They've donated this back to Apache. I have to wait and see how this project changes. If this comes in, then in our belt of open sources that we could experiment, this would be a great addition. So that's something that I'm really excited about. And of course, as you can see, this was very recently done, last month. I'm looking forward for any move that is happening on the spectrum. So in that case, you will see that all these kind of multimedia, machine learning, and deep learning becomes very default. Of course, as a whole industry, we are pushing to see what next for transformers. There are like 3 or 4 replacements that we have discovered, but nothing is mass engineered. Everything is very prototypey and discuss it on the discussion, as you can see on the platform. So I thought I'll give you close this session by giving you a few ideas. And of course, we have question sessions that I want to take up. One is you can look at contamination reduction and product prevention. There are a lot of things that you can do around it. As I said, vision is a great area. So there's plenty of image recognition models that you can build. You can also look into hotspots, right? Like sorting at the source bins. And one early way is to give feedback, so that there is where the reinforced learning algorithms can come a lot in your habitual training and behavioral training, like disposal habits, creating guides, and creating guide practice books for recycling and so on and so forth. So that becomes more prevention than fighting it. The other idea I thought about was on the sensing. So you don't have to sense just on one or two ways. You can always look at multimodal sensing and fusion. You can bring in lateral data sets. This is where streaming comes into play. There was a recent idea that one of my research friend was experimenting of using X-rays. I'm sure there are many more that's happening around in many other universities and faculty. So these are some of the things that comes to my mind. And of course, we can also look into patterns. Why I say this patterns is because there's so much behavior understood from e-commerce kind of logs and machine generated behavioral dumps that is being studied. So very similarly, we can start collecting machine collected data from robotic arms, from the sensor sorters, and many others, and start looking at behavioral patterns, which basically helps us to uncover potential innovative spots. Okay, so that's again one area. Of course, logistics and collection centers can always be researched. There's so much can be done on route optimization. How do we do preventive maintenance? Preventive maintenance has been done very much on the industrial sense, but we have not done so much on the waste management. Yes, that's something that we can look at. And of course, more and more image based analysis. So, this was some of the ideas. Currently, we have around 2000 plus trucks zigzagging the city. So the other day we were idea smithing about how we can work on the data sets. So these were some things that we spoke about. Of course, another big thing that my boss is interested in is upcycling, as he calls it. There's a big trend happening with our Gen Zs, whereby they take in their grandmother's memorables and then upcycle things. This is happening in fabric because fabric seems to be a big part of the landfill next to plastic. Of course, plastic is a headache, and fabric is close to that. I also understand that there are cities in the UK and somewhere in France and one more in Indonesia trying to experiment lab generated cotton, because cotton is the biggest carbon footprint creator, as you can guess. So a lot of upcycling idea comes in. So I was thinking about some of them in terms of waste recycling and waste upcycling. Of course, the last part, but to me, a very interesting part is we spend so much on psychometric profiling. We use that on only job recruitment and water sensitivity analysis. But actually, this kind of behavioral science can be applied a lot to human being, because we have created the climate crisis. No one else can fix this except human beings. So if there is some change that has to happen, it is about the human behavioral changes. So there's a lot of things that the city can do in terms of engaging and congruently correcting behavioral science as well. Okay, so there's so much that can be done. So these are some places that I thought I would idea smith. Of course, not that Singapore has explored every area, but we've been thinking about some of these things. So I just generalized whatever I looked into in the literature. So I don't know whether I have given you inspiration or confused you, but in my little experience, the fastest scaling happens with AI engines. So they are very easily scalable solutions. But the biggest hurdle to this kind of AI innovation is one, data scarcity, and two is translating them to achievable goals. So we have all these very sophisticated models, but how do we power our business or our government agencies goal is a big challenge. So these two to me are still big hurdles. So we have to start in introspecting on these perspective. How do we lead? How do we become model prototypes, model society? And of course, it's a call for action. So it's about everybody participating. I remember I read this quote, and in fact, I quote this in every possible big conferences that I talk. Cooperation is a thorough conviction that nobody is there until everybody goes there, and that's always true for waste management and recycling. So it's a thorough conviction. Everybody has to go there. Only then we can call that as a done task. I've purposely avoided the very specific ARIMA, all those kind of algorithms that we normally use in our coding platforms. Instead, I just try to keep the ideas very generic because I don't know the exact profile and the background of all the faculty who participate in this. If you are interested in doing any of these and you have data sets and you're interested in partnering with us, you can always drop email to me, and if I have the skills I participate, at least I will point you to the right person otherwise. Okay? It's always a good option to talk about my institute and my city and the work. Thank you for the opportunity. I think that's pretty much what I have as the talk here. So I will stop the sharing and I'll open the floor for any questions. If you have any questions, I'm happy to take them.
Yeah, ma'am. Good evening, ma'am.
Hi.
Yeah, good evening, ma'am. First of all, I want to say thank you. So, entire session
Yeah.
was
Thank you.
so informative and insightful, ma'am. So, I'm one of a research scholar from Sastra University. So, I basically my question is from cloud environment, ma'am. So, we know already zero trust architecture is enabled in cloud-based environment, right, ma'am?
When you say zero trust, it's about security.
Yeah.
Okay.
Yeah.
There are
Yes,
too
ma'am.
many names. So,
Yeah. Yeah.
yeah. Yeah.
Still, I'm not
So,
complete my question. So we are already have zero based architecture, trust architecture. So how we can implement in this concept in IoT based environment, and how we can mitigate this one, and how it will be differentiated from the normal firewall systems.
it's a brilliant question. See, in general, security has also evolved a lot. To answer your question, I have to go back a little. You see, we call certain kind of technologies as disruptive technologies. The first disruptive technology we had is cloud. The next
Yeah,
disruptive
yes, ma'am.
technology that we came across is data, big data. The current disruptive technology that everybody is talking about is AI, and the very less explored area is IoT. So all these four, when I say IoT, it is not just devices, so it's web, mobile, tablets, everything. Instead of IoT, in Singapore, at least in my institute, we have started using this word called edge. Okay, so edge is the last
Yeah,
disruptor.
edge devices.
Yeah,
Yeah, yes,
edge is
ma'am.
the last one. So when you say zero trust and all these things, these are back end services, which has been very established because if you see cloud native architecture, we have standards. We have so much standards that we basically have a full science of how do we expose these kind of service techniques, API based on the big data on the cloud using AI models. All these things are very standardized. And of course, we have very good moderators in the community to do these things. But Edge, on the other hand, is very unexplored. And rightfully so, because we see that Edge is the most fragmented society as of now. Because cloud basically, even though it is a vendor
Yes.
game, you can simply put them as 30 to 50 vendors, cloud vendors,
Yeah, yes,
in
ma'am.
total. But when you say
Yes, ma'am.
IoT, there are million vendors out there. So your
Yeah, yes.
fragmentation is in terms of protocols, in terms of formats, in terms of devices, intelligence inside the devices. It's a very constrained area. So you can't get that
So
zero trust in one day.
yeah,
It's
yes,
going
ma'am.
to take
Yes,
time.
yes, ma'am.
And
So that's
not
why I'm
forget,
asking.
yeah.
Yeah.
Not forgetting to mention the government is also raising on 5G, 6G, etc. So we have just
Yeah, yes,
started.
ma'am.
Maybe give it another 10 years, then probably we'll have some categories there.
Yeah.
That's the
This
best
was my
guess.
biggest question. Yeah. Thank you,
Yeah,
ma'am.
that's
And one
why.
more question, ma'am. Yeah, one more question, ma'am. So how we can enable that disk side management in IoT based system, ma'am?
See, we at the moment, what we are trying to do in my team is we look at IoT gateways. eh. Um, if you go into the Kubernetes standards, we basically are trying to look at a way in which we can do probing. There is some levels of we have a way to implement SLA. We call them service level objectives, and then edge gateways as we do it. But when it comes to disk array, I don't think we have a full architecture yet. So we classify stateless, stateful, all these things, and persistent store is not yet very much explored. It's very much on the internal lightweight databases, because the moment you say edge, it's a constrained programming. You have constraints in terms of power. You have constraint. So yeah. So persistent store is a long way. At the moment, it is more in-memory devices.
Okay, thank you, ma'am. Thank you so much, ma'am.
Thank you, ma'am. I also have a question.
Go ahead, please.
From your experience working with the multiple industries, and what do you see as the biggest barrier to adopting AML based solutions in waste management? That is it cost, technology readiness, or a public awareness? Which one you
Two
mentioned?
hurdles, Manjula. Number one, data is siloed. Nobody wants to share data. Two, technology is expensive. These multispectral cameras are basically impossible to reproduce in university labs. eh. So we basically depend a lot on general public funding and collaborators. To me, these two are the biggest hurdles. We have sophisticated models, so I don't think we have a lack of model understanding. There are in fact, thousands of models. So making them practical is big challenge, because we don't have data and we don't have the money that we want to buy all these kind of hi-fi technologies. There are a lot of prototypes, and I have to sadly accept that sometimes industry is way ahead of us. The whole thing started with cloud. Cloud academic standards was always a catch-up game. The vendors were upfront, and big data, it slowed down a bit, but still it's a vendor game. With AI, thanks to many of the open libraries like MATLAB and Spark, and it's still very much transparent. With Edge, it's going to repeat the same cloud history. It's going to be very vendor dominated. So technology transparency and data are the two big headaches for us.
Thank you, ma'am. Thank
Thank
you.
you. There's a
And
lot of
then
thanks, and thank you for all the messages, but I don't have questions, so I'm not taking. If you're very shy, you can put the question on the chat, and if I see that, I'll answer that.
and
I keep
one
reading
more
the chat
question,
as well.
madam.
Yes, please.
One more question, madam. You mentioned e-training opportunities in this field, like madam. Could you share how such training programs are structured in Singapore, and how participants from India could benefit or collaborate in these kind of
We
initiatives?
highly recommend coming here. eh. If you want to learn from us, come see. And of course, you're always welcome to share. So there's a lot of um, on campus and industry agency tourism available, which is happening via the universities as well as the foreign affairs ministry. So look out for those courses. They basically are being conducted by tertiary education institutes, as we call them. So that's the best way to learn, because there is how much ever you are a digital nomad, in-person experience is always not replaceable. Okay? So to me, that's the best way to pick up such kind of research innovation. So do look out for the program flyers, and maybe your university can sign up for them. Of course, you don't have to stay here long. There are programs that are conducted for 5 days, 7 days, etc. So you can look out for such.
Okay, thank you, madam. Thanks a lot. It's a time
Thank you.
for concluding this session. So on behalf of this organizing committee, I extend our heartfelt gratitude to Dr. Surya, Principal Lecturer and Senior Consultant at the National University of Singapore, for delivering such a thoughtful, thought-provoking session on intelligent waste segregation and recycling using AML. Your vast experience and deep insights into AI and ML applications for sustainable waste management have truly broadened our perspective. The way you connected through just like Singapore's unique waste challenges, the recycling gap, and the relevant case studies also you have mentioned with advanced technologies also, and it was very highly enlightening. In addition, you emphasize on e-training opportunities and the emerging research areas, and evolving role of data engineers has opened new horizons for our participants, encouraging them to think both globally and also practically. So we sincerely thank you for taking the time to be with us, ma'am, and sharing your expertise. Let's thanks a lot for your wonderful session, madam. Thank you.
Thank you very much, guys. I'm humbled. Please be connected. My email is available with the organizers. Otherwise, it's surya@nus.edu.sg. It's easy to stalk me in LinkedIn. Thank you, guys, and good night. Can I end the session?
Yes, ma'am, you can.
Thank you very much. Thank you.
Good night. Good night, madam. Dear participants, please stay online. So the next session is going to start. So can I check with you, the resource person Rahul Sai, Mr. Rahul Sai is there. I hope he joined. Sir, are you there? Good evening once again. The next session is going to start now. The next session will be using Azure for managing smart waste IoT platforms. We are delighted to welcome Mr. Tamisetti Rahul Sai, Senior Cloud Data Engineer at Vision Technology, Bangalore. Mr. Rahul is a results-driven cloud data engineer with more than 7 years of experience in delivering scalable data solutions on Google Cloud, AWS, and Azure. He has worked with leading organizations including Vision Technology, TCS, Tridents, and DXC Technology also for contributing to projects in customer data platforms, supply chain analytics, and cloud migration. He holds multiple certifications including Google Cloud Professional Data Engineer and Microsoft Azure Fundamentals, and has deep expertise in Databricks, BigQuery, PySpark, and ETL pipelines. This evening, he will enlighten us on how Microsoft Azure can be leveraged to efficiently manage IoT-driven smart waste management systems, bridging the gap between the data engineering and sustainable urban solutions. We extend a warm welcome to Mr. Rahul, sir, and we eagerly look forward to your session. Welcome you, sir. Sir, you can start the session.
Hi everyone. Sorry, actually I had some issue. I'm still not able to present in the Teams. Can someone? Can you guys hear me?
Sir, I made you as a presenter already. So can you able to share the screen, sir?
No, I'm still not a presenter. I can see.
You're a presenter only, sir.
Yeah. 1 second.
Yes.
No, it shows only meeting organizers and presenters can share. I can unmute and camera is fine, but if you can give me a second, I can join from another one, maybe.
Okay, sir. But I
Yeah.
I made you as a presenter only. Can you try
Yeah.
once, sir?
Okay. Yeah, I can.
Is it okay, sir, now?
Yeah.
Okay.
I hope you guys can see the screen.
Yes, sir. Yes, sir. Visible.
Okay. Yeah. Thank you all for giving me this opportunity for this schedule. I mean, faculty development program. Been so. As already the presenter has given the introduction about me, I have around close to 8 years of experience in cloud data engineering. I've been working with, in GCP, Azure, and AWS clouds. And also, predominantly I work into data engineering stuff. So in terms of data engineering, right? So processing huge amounts of data using Hadoop, Hive, Spark. Later, we have been started working on the streaming tech as well. So this is pretty much about me. In terms of professional works. So without any ado, I'll start the session. Uh, so majorly, I'll be talking about waste management using smart IoT devices and Azure. Using Azure services. So in terms of these solutions into waste management and especially IoT devices, I'll not talk about much of the waste management. I'll more talk about the technical stuff. So because all the other sessions I've been seeing, so there was a lot of information has been provided around that. So So in terms of, okay, in terms of challenges, right, current what we have around traditional waste management, the current state of it, what exactly is the problem with it, and then I'll take it forward to the solution and what is the architecture that would help us to achieve this kind of a solutions. I mean, smart IoT devices along with Azure related services that can be used for the solution. Okay. So in the traditional waste, the current state, right? If you see the method of collection of waste and also the way that they travel. Let's say, for an example, take a city of Bangalore or Hyderabad. So it's a lot of area to cover and a lot of streets, layouts, and all needs to be covered. And they are currently basically following the fixed routes. So basically, they may say like, okay, weekly once or twice we will come to collect the waste, and that to specific dates. So, but the problem with this is, so let's say there would be I mean, basically the users who are being, let's say for restaurants, they will have wastage on a daily basis. For an household, it may be different. 2-3 days it can hold, right? So it's based on the usage, it changes. So basically, it is not a right way to collect the waste. So, and also the schedules are also off. So this is where the issues comes in. The places get messy, and also operational costs will increase in this kinds of a process, and also fuel consumption. So there is no waste in particular area. For an example, I am taking. In that case also, because of the fixed routes, they has to travel, and also they have to try to collect the waste, even though there is not I mean, sufficient waste to collect, right? And also some places where public places where basically waste bins are all overflowing because they have to wait until the next schedule is, right? So that and all is there, and also environment impact will be there. So in terms of environment impact, so because of these waste managements, so if you are not able to clean up the waste that is being there, so a lot of health related issues and also maintenance and cleaning related issues will come on. So these are all the issues that we have with the current traditional waste management, right? So in order to use IoT devices, smarter way to upcome related to the issues, so we have to do it using uh, upcoming technologies like IoT, cloud services, and also management of the things, right? So in order to achieve this solution, so what we can do is, so now IoT is a really exploding thing, as you already, all of you are aware, and also cloud is already in there in the industry, and I've been using drastically, and everything is moving into cloud nowadays. Everything is moving from legacy to all the new text. Everything is building it on top of cloud technologies only, right? So for this one, the key capabilities that needs to be there for this particular solution, right? So it has to be real-time data. So let's say there are smart bins. Smart bins, when I say smart bins, so we need to have a bin, dustbin, or basically waste-related bins that are capable enough to send some data when what is the level of garbage it is at that particular point of time. So let's say there would be 25%, 30%, all the way to the 100%, 0 to 100%, it can vary. So this data, it has to share with the uh, right authorities so that they can work based on the data points. So this is the thing. So for this, the key capability will be real-time data from the smart bins, right? And also intelligent route optimizations. Let's say there is particular area which is there are a lot of bins that are being filled, so that will become our highest priority. And also in which way, if we go for all the bins, it will be an optimized route so that you can reduce the fuel cost, right? So this is one thing, that intelligent route optimization can also be done using this smart waste management, and also predictive maintenance. So predictive maintenance in the sense, let's say for an example, there are multiple areas in a city, right? So in multiple areas, certain time periods, let's say for an example, if you take Ganesh Chaturthi, which is happened recently, because of the celebrations and parties and all, there would be lot of waste, right? That has been collected into the bins. So that needs to be cleared. And also based on that particular time period, they need more people, capacity or resources that needs to do the job. So that also been varies, depends on the time period. So that also you have to predict. So today maybe 10 people are sufficient to do the job, but tomorrow or day after tomorrow they may need 20 or 30 people. So based on the data, we can predict, and also accordingly we can be prepared for that, and then you will be able to do the job without any hiccups, right? These are the key capabilities for the smart waste management. Next comes to the okay, so this is a diagram that can showcase what exactly happens. So these are all the smart bins that are being placed all around the city, whichever city that you take. And also these are the trucks that will collect the garbage from the bins, right? So if you see, all the bins are basically IoT enabled, or IoT devices are placed along with, I mean, sensors and all, everything will be there. Based on the sensor readings, it will be able to know how much it is filled up or how much it is going to be filled up on a particular day. So that accordingly, the next day plans will be scheduled for the field people to do the job, right? And this is the framework which is IoT enabled management. So that I'll come up with an, I mean, I have already come up with an architecture. I'll be explaining it in the further coming slides, right? So if you use this, what are all the impacts, right? So economic impact, you will be reducing your cost, and also you will be environment impact will be there. If you will reduce the CO2 emissions or other hazard, I mean, basically you will be able to reduce the diseases that because of this waste that spreads, right? And also people will be satisfied with the performance, and also you will save a lot of time and money. So these are the key impact that is going to happen if you implement this kind of a solutions in a city, right? Okay, before going to the architecture, right, I wanted to explain about the Azure services that we are going to, I mean, that I have been going to use it in the architecture. So predominantly, if you go to the Azure services, there are a lot of services that you can use, lot of ways to solve this particular problem, right? So it's all comes down to the implementation and the use cases, right? So for now, I have considered few services which we can achieve this solution. In that, out of which Azure IoT Hub is the first and foremost service, which is what it does is it basically manages cloud services, right, in a central message hub. Basically it communicates between internet IoT devices as well as the backend application. So there are IoT devices already being placed in the bins, right? Now it is generating some data. So that data has to be sent to some application to process this data so that we can act upon this data, right? So this is what Azure IoT Hub does. So it is a link between the IoT device and between the backend application. Backend application can be of anything. It need not to be a specific UI, or it need not to be a storage layer. It can be anything, right? So this is what Azure IoT Hub does, right? And also as it comes from the Azure, it is already secure and reliable. So basically we can connect to the IoT devices, monitor, manage. So basically one more key point to mention here, right? This Azure IoT Hub is a two-way direction of a communication. So it will receive the data from the bins, basically from the IoT devices, as well as it will be able to send a message from Azure IoT Hub to the IoT device. So it's a bidirectional communication, and also it's very easy to scale. So usually in the IT industry, right? So scaling is a big challenge. So it works for 10 users. It will not work for 10,000 users because of the scale. So the application or the programs or the services that we create, it will change the behavior over the scalability. So scalability is one more thing which comes by default for Azure IoT Hub. You don't need to worry about it. So basically, as you know already, Azure services or any cloud services as pay, basically you will use, and then based on your usage, you will pay, right? So you don't need to worry about the scalability also in Azure IoT Hub. So it works for 1,000 devices, or is it even if it is lakhs of devices also, it works seamlessly, right? And Azure Stream Analytics. So this is also one of a service from Azure itself. So basically now using Azure IoT Hub, we are collecting the data, right, from all the IoT devices. Now it has to be managed, basically process this data, and then based on this data processing only, we have to do what, basically we have to do the actions. So where it has to be cleaned, how many people are required, and at what route if you go, you will be able to collect all the bins that are being full and with a minimal cost, right? So this related data analytics and all will happen Azure Stream Analytics. It's kind of a real-time data processing, right? And also with a low latency. Latency should be less for the real-time data, because if your latency is on higher side, there is no point of using real-time data, right? So these are the two major services. There are other services as well that we will be using it in order to solve this problem. So ADLS Gen 2 is one another service from Azure itself. So basically it's a storage. It's a generation 2. So there is a generation 1 as well, which is a blob storage. But blob storage is basically supports only object-oriented storages. It doesn't support hierarchy of folder-like structures to manage the data that we are being stored. So that's where the ADLS Gen 2 comes in, where it is a scalable, secure, cost-effective solution with a high performance, and also it's easy to manage. So you will be able to store objects as well as the files or any kind of sort of data that you wanted to store. Even audio, video, or even it comes to files like CSV, JSON, or any other file formats in ADLS Gen 2. And also Azure Functions is the one other service that we will be using for the computing purpose. So in terms of computing purpose, there are a lot of things. You have basically you will be able to use Azure Databricks also for the compute, or Azure Functions, or there are other services that can be used. Based on the use case, we will be choosing the service, which one will be best suiting for our use case. So based on that, I have used Azure Functions because Azure Function is a serverless compute. So basically, if you want to run a small thing, small computation that needs to be run, you can do it. Or even if it is a large amounts of data, even still you can be able to do it based on it will be able to upscale or downscale, and whatever that we use for that only you will be able to. I mean, basically you will be paying. So so it is ideal for the lightweight and scalable applications for auto-task response to events. Based on events, if there is a new event is happening, then only it will trigger, and then it will do the job, and then it will go back to the state where it was. So that is one service. So I'm only mentioned only key services that are being used. There are other services. When it comes to architecture, I'll explain. Right. So this is the architecture, smart waste management using Azure Cloud Services. So these are the bins, the smart bins that we have been discussing, and this is the Azure IoT Hub. Like I mentioned earlier, it's a linkage between the backend application and with the IoT devices. So this Azure IoT hub will collect the data from smart bins and it will be taking it to the storage. It will be either database or even data lake Gen 2 storage. So either ways you can store it. But only difference would be databases are cost bit higher than the data lake storage, right? But the response between these two, the latencies will differ basically. So as soon as we get the data, we store it, and also we try to process this data. Azure Stream Analytics, using this service, we will be processing this data, right? And also in Azure Functions, after this processing of this data, it will send downwards to the analytics and decision making. So we have this data. We collected the data from the smart bins, and we have streamlined it, and we have stored it in the storage. Now, what is the point of storing this data, right? So it has to be processed, and it based on this data, we have to take the decisions. Okay, so in particular area, there is a lot of bins that are being full, and it has to be taken on priority and collect the waste today itself. So this is the priority. Now you get the data from the smart bins. Now it is being processed. Now you have to take the decision whether today it has to be cleaned up, or tomorrow or day after tomorrow. Based on the data points, you have to take the decision. So for that, in Azure Functions, we have to do the programming, right? So the criteria and all we have to come up. It varies from use case to use case, or city to city itself. So a few things will work in Bangalore, but it has to be in a different manner in Hyderabad because of the geographical locations, or it can be the way that they are operating, right? All those things we have to consider. Accordingly, we have to do the programming. So it is kind of okay, if you come up to 80% of the bins have been filled in a particular area, that has to be cleaned up the very next day. This is the criteria. This is the trigger that we will be using. So this criteria, triggers, and all will be configured in Azure Functions, so that you, accordingly, the downstreams, basically the downstream application would be a field user or a application, right? So here the end users would be, let's say there is a municipality. So municipality authorities will be there who are handling this waste management, and under his management there would be a lot of workers that will be working, right? So they will have an access to either an application that can be built using Azure Logic Apps. If you want to go for a native Azure service to build an application as well, that can be used by all the people who are working for this particular waste management. So the data will flow from here to here, right? So the decision will be taken care here according to the final result. It will send through an email, SMS alert, or even an application alerts will go, and use application. The field people will be using application to know where they need to collect next, or in which route they have to go on collect the bins. So this and all they can see via this application, which is being end user for this particular field. And also there is another way of using this data is like the higher officials can build a dashboard which can show their data points. Okay, last week how they did, and before that week how they did, and what they wanted to achieve. So targets they can fix. Okay, they are able to clean up the waste around 60% this week. They wanted to make it 70% or 80% next week or next month. They can decide these basically targets. Accordingly, they need to increase the number of people that are being working, that they can hire and deploy, so that the process will be quicker and they can do it further. So these are all the services that can help us to achieve this solution, right? And also in order, I'll explain all the things that we have discussed. Basically, IoT Edge will be there. This is basically intelligent devices, nothing but IoT devices, which are installed in the bins. That will be our source. And ingestion, right? The data from which is collecting from the IoT devices that has been need to be ingested into the storage, right? Using IoT, how we can do that. And processing, we have, as I discussed, Azure Stream Analytics is one good service that can be used. Just to mention here, in terms of processing, there are a lot of other services that can be used. Like I mentioned, okay, Kafka is one thing which is popular in terms of streaming data. It will also do the same thing, but Kafka is an open source, and also you have a paid version for the Kafka itself. So based on use case and costing and all, we can decide which one to use. And also we have there are in, let's say, if you see in GCP, they have PubSub, which does the same thing. It does the streaming data processing on the fly, and it is from GCP cloud, right? And also we have something called Spark. Spark is basically very famous for the data processing, not just a data processing. It deals with the huge amounts of data. There are modules inside Spark itself, which can basically, there is one more module which is Spark streaming, which can be used for the streaming related data. So Spark supports batch as well as stream data, right? So in order to process this data, we can use Spark as well, right? And in terms of storage, like I mentioned, ADLS Gen 2 is the good service to use in Azure, because the cost is less, but the scalability and reliability is higher on the storage side. So in terms of storage, there are a lot of classes that can be defined. So based on the data, let's say you have data from last 10 years, but we don't need last 10 years data to be kept in a storage class where the costing is higher, right? In that cases, we can archive this particular data which is older, right? And then we can save the costing on the storage part. So these things and all we can do. So in terms of actions, so as we discussed, we collect the data, we streamed it, and we have processed it. But how you will take up the decision? Who will take this decision? What needs to be done and when needs to be done? Who will do this, right? That's where we will come to Azure machine learning services, right? To predict the fill rates of the vast bins. So we have a service called Azure Machine Learning. This is the service, again, the name itself is the Azure Machine Learning service. So if you use this machine learning things, so based on the data that is being provided to these services, it will understand the patterns of usages, and it will come up with, okay, this particular area, the bins will be filled by day after tomorrow. How it comes to that decision or the point, right? Based on the last 3 months or 3 weeks or 1 month of data, whichever. Basically, we have to train this model. So based on the training that we data that we have provided on the data points, it will come up to that. Okay, this is the date that these are the bins that will be get full. So by this time, there should be a scheduled wastage collection should happen, and accordingly it will assign to the, it can assign to the people. Okay, let's say there are 10 people who are working in a particular area, right, for the waste collection. So it will get, that people can get notified, okay, on this particular day you have to collect waste from this particular area and these particular roads, so that they will have an idea, okay, today I have to go to this particular area and collect the waste. So that also can be done using machine learning service, right? And there is something Azure Maps as well for dynamic route optimization. So this is nothing but like just like Google Maps. So for an example, think of it this way: you have 5 places to go, right? We have in maps, we have destination A, B, C, D, E. Likewise, you can be able to um, pinpoint the locations, and then it will show you which, if you go in which route, you will be able to cover all the places within minimal distance. So Azure Maps also does the same thing, simple way, but it is for the industrial applications, just like this one, the waste management. And also so basically it will have the maps related data as well as the traffic information. So there is a particular route which is heavy with the traffic at this particular point of time. If you try to collect garbage in that particular roads, right, you will be stuck in traffic for 1 to 3 hours. Like Bangalore, like city, if you see, it's quite often traffic jams will be there. So you are wasting a lot of time in traffic instead of doing your job. So based on this data, it will be able to suggest you, instead of taking this route, take the another route, collect the wastage there, and finally when the traffic is reduced in that particular B point area, go there and collect, so that you are efficiently routing the maps, and you are reducing the amount of wastage of time, right, and also resources. So this is one advantage with Azure Maps that we can leverage, right? And also finally, one user interface where city authorities or users or the waste management departments can utilize. Either it can be a web application or a mobile application. Like I mentioned, Azure also provides an app service. We can leverage that, or even people want to go with something built on their own, they can do that. It's only matter of thing is basically you will link the data from Azure services to the UI, and UI will be able to project all the information in the web or mobile. All things happens in a real time. So, right. So with this, what impact that we are bringing in? So economic impact, which is utilizing the funds in an effective manner, and also return on investment. So you have been spending lakhs of rupees for this, and you may end up saving couple of lakhs out of it. And environment impact, like we already discussed, it is sustainable, and also it will reduce the carbon emissions and also landfill waste, right? So by collecting all this waste and processing it in processed, right, so segregating it, recycling it, or making it compost or other things, you will be able to generate some more revenue, which will be again help the city to keep it clean, right? And also society related impact would be cleaner streets we can see, and also pollution will be reduced and better quality of life for all the users. So not just this, if you try to emphasize it further, right, the expansion, what is the future we can do this. Let's say I am a user, I'm a citizen, right, where I'm staying in Bangalore like city. So I have an issue right in front of my house or in my street. If I want to report it and get it done with the right authorities, so we can integrate these applications into smart city platforms where city already being used. And if I raise a request, okay, today I have been raising okay, so and so area, so and so issue is there, there is a bin that has been overflowing and a lot of mess has happened, so I can raise their concern over it, and then directly this data can go to the right authorities, and eventually all the data will flow all the way to the field users, and field waste management people can come and collect. By end of the day they can resolve these issues, right? So that way it can help for the user concerns. So right, this is the future scope that you can expect. And if I mean, this is all for now for this session. I mean, in terms, but I am hoping that there are a lot of questions and a lot of discussion that I can help you with. Is there any understanding that needs to be done? I'm open for that kind of a discussions. Are we still connected? Okay. Are there any technical questions or clarifications that are required? Maybe a bit of elaborated explanation if you want, I can do, and particular services or how it can be implemented. Satya, you have been raising your hand. I think I am allowed you to unmute. Can unmute and talk if you want.
Good evening, sir. Am I audible?
Yeah, I can hear you, Satya.
Sir, my doubt is actually have spoken about the ROI and all. If I'm going to implement this for at least 3 streets, may I know the cost which will?
Satya, basically, we cannot define costing based on streets, right? So that tech is where the costing involves in terms of these particular architecture, right? If you use it for 3 streets or 300 streets, the costing will differ very minimal, right? Because you are using storage, you are using IoT devices, you are using all the other services which are being costing based on how much we are using, right? But even if there is a limit to the usage, so beyond that point only it will come to more costing. So instead of 2 or 3 or less number of streets, I would suggest to go with the cities, all over the cities, or at least certain areas, at least if not all the city, maybe 5 to 6 areas that can be utilized. Because if you are going for less amount of area and doing it using all this tech, it won't be ideal or choice, right? You are spending a lot of money and you are getting less results, right? Yeah. Any other? Okay. Yeah, Arunakumari.
Good evening, sir.
Yeah, good evening.
Yeah. Using Azure services, can we do a small pilot project? Can we encourage the students to do a pilot project in the local area for them as a community service project like that?
Yeah,
if
definitely.
It is so, how? Yeah, you can proceed, sir.
Yeah, so basically it is definitely possible in terms of Azure, right? So you need not to pay up to some extent, or also there is a free credit that is being provided by Azure. So let's say, for an example, you are an user, you can create an account in Azure, and you will be given some compute, some resources that are being free of cost. So all the services that we've been discussed, we can utilize it to up to some extent. So if you want to do it for a large scale, then you need to pay amount and do it. But otherwise, for a project level or POC level, you don't need to pay. So it is pretty much possible. And also, only thing is you need to get IoT devices which can send this data, right? So let's say, for an example, at least you have 2-3 bins that are for the POC level, right? Proof of concept. And then if these IoT devices are able to send this data, then everything else which is on Azure, you can do it with that free account itself, and you will be able to see the results as well. You can use Power BI for the dashboard level if you want to do it. And also for application and all, like I mentioned, app services are there. You can create a basic applications or and then you can see the data in real time.
Is Azure supporting serverless computing, sir?
Yes, all the cloud has serverless compute. So there are server based computes also. If you know how much compute that you are going to consume, then in that case, you will go with a compute, which is basically not serverless, right? If you don't know how much the data can go up to and come down to, in those cases, serverless would be an ideal choice, because in terms of serverless, the costing would be a bit higher, because you are not specifying how much that you require on a daily basis, so that they need to keep a reserve of the resources, so that if you come up with a request that you need more servers immediately, then they should be in a position to provide. So for that reason, the costing would be higher for the serverless.
So one other question is regarding what is the criteria, that is, do we need a Microsoft account for accessing Azure?
Yes, yes, it is mandatory Microsoft accounts that needs to be created. If you go to Azure portal, you will be able to sign up. At that point of time, you can give even your any email ID, and you can sign up. There is no
Can we
other
go
restriction.
with our institutional Microsoft account, sir?
Yes, you can use institutional as well. Yeah.
So up to what level we can use the Azure services with institute level Microsoft account?
No, institution level, I'm not particularly sure. Is there any specific allocations? Usually for the corporate sites, if the company is a partner to Azure or any other clouds, they usually give some credits to do the POCs, right? And then get hang of the accounts, and then finally they will be customers to them. So trainings and all will also be provided as part of partnership programs. But at college levels, I'm not sure. But as an individual user, you still be able to get around $300 credits by default. That can be utilized.
It is $300 credit.
Yeah, I think it changes from time to time. Earlier, it was the case. Earlier, they used to give more credits when was in the initial stages, but now they may have changed it.
Okay. And nowadays, all the cloud service providers have changed their subscriptions. We are unable to make the students work out. Previously, we used to have free subscriptions and we have given practical exposure to students, but now it's very difficult for us to give practical exposure to students because of these limitations.
Yeah. But still, the program is there for free credits, but only one time one user can get it. So it was around 3 months of the time period. Whether you use it or not, doesn't matter. It will expire.
So can each and every student get such type of facility subscription?
Yes, each and every student can get. But only thing is, while signing up for this account, it may need to require a debit card or a credit card for the billing purposes. If you overuse it, in that cases, it will be chargeable. For that purpose, you have to provide those details.
Okay.
Initially, they will deduct only 2 rupees, and then you can activate the account and you can use it.
Okay, sir. Thank you. Thank you very much.
Yeah, thank you. Sai Kiran, you had questions?
So if no questions from the participant side, we can conclude our session. Thank you, sir. On behalf of the organizing committee, I extend our sincere thanks to Mr. Tamisetti Rahul Sai, Senior Cloud Data Engineer at Vision Technology, Bangalore, for his excellent session on using Azure for managing smart waste IoT platforms. Your clear explanation of Azure-based solutions coupled with the practical industry insights on IoT platforms and scalable cloud data engineering has given our participants a strong foundation in applying cloud technologies for sustainable waste management. The hands-on perspective also you have shared will be very immensely valuable for both the faculty and researchers who are attending this FDP. So we are truly grateful for your time and efforts in making this session so engaging and informative, sir. Thanks a lot for this session. Wonderful session. Thank you so much.
Thank you. Thanks, everybody. Thanks for your time as well. If you need any further things, I will be able to help. Please do reach out without hesitation. Yeah.
Thank you. Thank you, sir.
So is there anything else? Or are we good to close the session?
Yes, sir. We can wind up now. They're attending the feedback sessions.
Okay.
Feedback
Okay.
link we will share, sir. Thank you, sir.
Thank you. Thank you.